now. So I'm going to share my screen and we can start. Boom, boom. Where are you? Where's my R? Where's my R? Where's my R? Where? Awesome. Okay, can you see my screen?
Yes.
Beautiful. Okay, so we're going to start on a fresh page so that everyone will see. Those that are complaining that they cannot install this or they cannot see data set and stuff, we'll see. So I'm just going to start on a fresh page. So let's assume I just opened up my R Studio right now. And then I go to File, and then I click my new file, and then I click my R script. So it opens up a new script for me here. And let me just go ahead and save this file. I go to Save As. And then let's say we call it TOSARIF R training. So you can see the name has been changed to TOSARIF R training. So we're just starting. This is a fresh start. So like I said, the first thing you usually want to do when you come into your R Studio is you want to install the packages that will help you function in R. So let's assume we just want to work with a tidyverse package. We'll say install the packages, and then we put in our quotes and say tidyverse. Control Enter. So if you look at the console, it says package tidyverse is in use and will not be installed. And that is because I have installed tidyverse in my system already. Like I told us the last time, once you install tidyverse, once you install a package in your system, you do not have to install it again. Installation is done once and that is it. However, if you are going to start any fresh session, you need to load the package, and loading it requires you to use the function library, and you put in your package in there. That's tidyverse. So I'll click my Control Enter, and then I know it's loaded the package for me. So we go ahead. Ejiro had mentioned that she couldn't find data sets in R. So like I said, once you load what's it called? Once you've installed and loaded tidyverse in your system, you have access to hundreds of data sets you can practice with. And to find those data sets, all you need to do is to type data. Sorry about that. It's that voice. Data. And then you click your Control Enter. And you can see in this source here, all these are packages. Sorry, all these are data sets. You can see data sets in package data sets. Air passengers, BG cells, BOD, CO2, cheek weight, all of them are data sets. Let me show you the ones we've used. Let me see if we can see that. Star Wars. Where is it? But all your data sets are in here that you can use, you know. So Ejiro, so these are all data sets that R has given us access to just because we've loaded tidyverse in it. So you can use that. Okay, so we've installed tidyverse. And in the last two sessions, we've looked at R basics. We've looked at how R, the 4 quadrants in R and what their functions are. We've also looked at basic principles in R, like functions, objects, packages, the concept of a tidy data. We've just looked at all those. We also touched a bit on operators in R. So we also looked at how to explore data using various functions. We talked about the glimpse function. We talked about the scheme function. We talked about structure. We talked about dimension. We looked at names. We looked at head, tails. We looked at unique. We looked at class. So all those are functions that you can use to explore your data and understand what your data is all about. And then we moved from that into data cleaning and data manipulation, where we looked at functions like how to rename a variable, how to recode a value, and all those kind of things. So today, I want us to dwell more on how to describe your data and how to summarize your data. And if we have some time, we might move into visualization of data. So I'm going to use, like I said, we have data sets in R that we can. I'm so sorry about that. There's a voiceover coming from our radio room and it's obstructing, but I'm sorry about that. Okay, so now the way I want us to really look at R is how to use R data analysis concept to solve real world problems. I don't just want us to look at it as, oh, it's just a tool for data analysis, you just analyze data. No. I want us to picture it that, okay, there is a problem, or there is something we want to, there's a challenge we want to solve, or there is an answer we're seeking for, and then we can use data analysis to solve that challenge or to deal with that problem in real life settings. That is the way I want us to see R, and that is how you make R very sellable. That is how you become a very strong, versatile person in R, when you can actually use it to solve real world problems. Okay, so I'm going to ask us to look at, let's.
Sorry, sir.
Yeah.
Sorry, sir.
Yeah.
Sorry, sir. Okay. From the data to get packages that one can work with, when you typed data and control enter, it actually showed us a lot of packages, a lot of data sets.
Yes.
Yes, that we can actually choose. But how can we choose one? Can you show us an example of how one can make use of any single of those ones?
That's what we're about to do now.
Okay, sir. Okay,
Good.
sir.
Okay. So now let's assume we want to work on a data set called mSlip. mSlip is a data set in R. mSlip. So if I just type mSlip and I click Control Enter, you can see in the console it has produced. You can see the command we type mSlip. It has given us that data set, which has name, genus, var, order, conservation, sleep total, sleep REM, sleep cycle as variables. You can see that data set is inside this place. Now I can also view it in a beautiful table-like form and say view with capital V, view, and then I put in brackets mSlip. Control Enter, and it will give me that data set in a tabular form. So the same thing we saw in the console, where we had name, genus, var, order, is the same thing up here in the source. Name, genus, var, order, conservation. So if you wanted to know about the, sorry, someone's, can you mute your sound? Someone is on the background. Can you mute your sounds, please? Can you mute your sounds, please? Thank you. Please, can you mute your sounds, please? Uzoma Amalachuku, please, can you mute your sound, please? You are in a meeting with everyone, and your sound is, please, can you mute your sound, please? Thank you. Okay. So please, everyone, put your sound on mute. Okay, so where was I now? I can't remember what I was trying to say. Okay, so this is how you look at your data set. You can just type the name of the data set and click Control Enter, or you can type View and your data set, and then you can also click Control Enter to show you the data sets in a tabular form. Can everyone put their sounds on mute, please? Your sound coming in is completely distracting me, please. Idris Adamu Egia, please put your sound on mute, please. I don't have to keep saying these things, please. It is very annoying when your sounds is coming into our training.
You know record the thing? Huh? You sure?
Okay, thank you. You see, when sounds come like this, it just makes me lose my thoughts, and I don't even know where we are now. Okay, where were we? Okay, so the person that asked this question, this is how you view data sets. Let's assume we want to view another data. There's another data set called CO2. So I can just click CO2 and Control Enter. And you can see in the console, it shows me the data. If I want to view it in a tabular form, I can just type View and then CO2, Control Enter, and you can see it gives me the table, the data set in a tabular form here. So whichever data set that is within R, this is how you view them. Then if you want to bring in the data set as an object within your R environment here, you can just assign it. For example, CO2, you use your assignment operator and you use CO2. Sorry. Okay, so you just do this, Control Enter, and you can see in the environment, there is an object for that data set called CO2. The same thing, if we want, we can do that for Star Wars. Star Wars is also with the mSlip we used, mSlip. You can use your assignment operator and put it in your environment. And you can see right here, we have mSlip has been put as an object. So if I just click mSlip on the environment here, it just shows me the table of that data set within the source here. So that's just how you have your data set coming. Okay. So having done that, let's go into data description and summarization. Now let me see. Okay, so this is practically what we're going to be doing today. We're going to describe and summarize data. And under description and summarization of data, we'll look at the following sub-steps. We'll look at how to find a range and a spread of data. We'll look at the centrality of data. We'll look at the variance. We'll look at how to summarize data. And then we'll look at how to create tables in R. So let's just be fast about it. So the range tells you about the spread of a particular variable or a particular data set. That's what the range talks about. And some of the functions that you use to determine the range are things like to know what the minimum value is in a particular variable, to know what the maximum value is, to know what the range is. Range is like the difference between the minimum and the maximum. And then to know what the interquartile range is. Interquartile range is the difference between the 75th and the 25th percentile. So using our MSLIP database or data set, we can just run these functions. So minimum of MSLIP, we're looking at the awake variable within the MSLIP database. So we're asking R, we want to know the minimum value of the awake variable. Let's just see please, can you mute your sound? Please mute your sound. I'm hearing voices, please. It's distracting my thoughts. So let's look at the MSLIP database so that you appreciate what I'm, okay, this is it. So if you look at the MSLIP database, it has a variable called awake, which is this one here. So we want to find the minimum value of awake, the maximum value of awake, and all the stuff. So let's go back to our table. So we said minimum, open bracket. Now the first thing you need to tell R is your data set, what data set you're working in, and then you now put a $sign and tell R the variable within that data set. So if I run this command, you can see in the console, it's telling me that the minimum awake time is 4.1 right here. If I run the second one is the maximum value. Run that. Sorry, what did I do? Let's run again. So it says the maximum value is 22.1. And then the range. So it gives us the range. The range just tells us what the minimum and maximum values are. So 4.1 is the minimum, 22.1 is the maximum. Then the interquartile range, we'll run that. It tells us that the difference between the 75th percentile and 25th percentile is 5.9. So this just gives us how the data, how that variable is spread, how it's spread around the mean. Then the second thing we're looking at is centrality, and centrality defines the middle point of that data set, the middle point of the data set. So we're going to still use the same awake variable within the MSLIP data set. So just tell R to find the mean, and then we'll put this, and then when we click Control Enter, it tells us that the mean is 13.56. You can see it down here in the console. And then we can also tell R to tell us the median. The median is 13.9. So mean and median are two measures of centrality of data. So those are two things that can tell us about the center of a data. Then the variance, we just type VAR and measure variance. Variance is like the square of the standard deviation of a variable. Control Enter. It tells us the variance is 19.82. So, and if you remember, when we were looking at data exploration, when we use the summary function, it also gives us some of this, most of these values. So we can just do that and tell R to give us a summary of the mSlip of the awake variable in mSlip. So we do summary, open our brackets, type mSlip $awake, and then click Control Enter. And you can see it has given us a summary of that particular variable. It tells us the minimum is 4.10. The first quartile is 10.25. The median is 13.9. The mean is 13.57. Third quartile is 16.15. The maximum is 22.1, which are the same values we found when we did all those functions individually above. And then, you know, apart from looking for the summary of one single variable, we can also look for the summary of the entire data set. So we can just tell our summary of mSlip, which is the entire data set. Control Enter, and summary takes each variable in that data set and gives us a summary. So you can see, for example, this is the awake in the console here. This is the awake variable, and you can see it has given us a summary, the minimum, the first quartile. So the same thing that we just saw up there is giving us, but it has also given us that for all other variables that are in this data set. Then sometimes you might not want the summary of the entire data set, and you might not want the summary of just one. You might want the summary of two different variables in one data set. Let's assume we want to find the summary of sleep total, which is a variable, and brain weight, which is a variable within mSlip. So we can do mSlip. So now we've introduced back our tidyverse pipe operator. You know, all this while we've been doing the normal base R coding, but now we have entered into tidyverse by using our pipe operator. So instead of doing summary and then write mSlip $sleep total, comma, mSlip $brain weight, we can just use our tidyverse pipe operator and just write mSlip and then put in our pipe operator saying and then. So already R knows what data set we're working on as mSlip. Then you can just say summary and type directly the variables you want to find the summary about. So if we run this command here right now, and so sorry, what did I do? Go back. Where are you? So sorry for it. Okay, here is. So if we run this command, click Control Enter. Object brain weight, not is it brain? I think it's brain underscore weight. Brain weight. Let's look at the data set and then let me find out what the problem is. So where's mSlip? mSlip is here. So is there a variable called brain weight? Okay, there's brain weights, BRAINWT. Okay, so that's it there. I think I made a mistake in the spelling I used. So remove this. Control Enter. What's still the problem? Object brain weights not found. Oh. Okay, let me use awake here. Awake. Enter. What is wrong? Enter. Let's see. mSlip. Summary. Awake. How come it's giving me? This one. Okay, I don't know what is happening here, but let's make progress. Let's make progress. Okay, so we've looked at this range. Uh-oh, internet is stable. Please, can you still hear me? I'm saying that my internet is a bit unstable. Can you still hear me?
Yes, sir.
Okay, fine, good. So we've looked at range and spread, we've looked at centrality, we've looked at variance, and then we've started looking at summarizing data. So now I want us to do some work, some practical work right now. Okay. So there is a data set in R that's called Star Wars. So let me frame a real world problem. So two people are making an argument that women, sorry, I'm sorry about that. I'm sorry about that. Okay, so this Star Wars is looking at, I think, animals, right? So what I want us to do from this data set is, I want us to compare the body mass index of humans within this data set and assess whether females are more healthier than males or males are more healthier than females based on their body mass index. Now, body mass index is a parameter that we use in health indices to assess health, to assess how healthy someone is based on their height and their weight. And the body mass index is simply your weight divided by the square of your height. And if it is within a certain range of values, we say one is healthy. If it is above those range of values, we say you are getting overweight. If it's below those range of values, we say you are getting underweight. So the body mass index is what we use to assess that. So within this data set, this is what I want us to do. Now, let me read this. In the Star Wars data, I want us to compare the average body mass. Sorry, this is mass, SS. Compare the average body mass index between males and females in the human species. Compare the body mass index between males and females in the human species. So let's just bring out a few things that we get. So it wants us to compare body mass index. It says it's between males and females, and it says it's in the human species. So three things. We're dealing with body mass index. But if we look at the Star Wars data set, there is no there's no variable called body mass index. However, we have height and weight within that data set. And we know that body mass index, which is BMI, is equal to your mass, sorry, your weight divided by your height raised to power of 2. Raised to power of 2. So that is the formula for body mass index. And then we're looking at between males and gender, which means we're looking at a variable there, which is gender, males and females. And then we're looking at the human species. So this is how we're going to do this work right now. So we're dealing with this. Let us just look at the Star Wars data set so that we can appreciate what is happening here. Star Wars, where are you? Okay, that is it there. Okay, so this is the Star Wars data set. Let me enlarge my screen. Okay, so this is a Star Wars data set. It has variables, name, height, mass. Okay, so it's mass, not even weight. So it's mass. Mass, hair color, skin color, eye color, birth year, sex, gender, home world, species. So we can see where that species is. So under species, it has several species. It has humans, it has droids, it has Wookiee, Rodian, Hot, but there's a human species there. So it means we're working with human species. Then it's asking between males and females. So this is gender, masculine and feminine. And then it's asking for body mass index. And we have height and then mass. So we can calculate the body mass index from these two variables. Okay, so let's go back to our data set, to our script. Okay, so first of all, we tell R that we are working on Star Wars and then pipe operator. Then let's first select. You know, I told us about the select function. We'll select the variables that we want to work with. And we know we want to work with mass, we want to work with height, we want to work with gender, and we also want to work with species. So these are the 4 variables we want to work in. And then our pipe operator. And then because we're doing some mathematical calculation, we don't want missing data to affect our answers. So we can just from the beginning say drop NA. So we've told R to remove the missing data within these 4 variables. And then next, we want to first get a variable called body mass index. So we use a function called mutate. We open up our brackets. So mutate does one of 2 things. Mutate either gives us a new variable or it overrides an existing variable. So we want a new variable called body mass index equal to. So, and then we want to calculate it with mass and height. And we said it's mass divided by height. Okay, sorry. First of all, the height we have is in centimeters. And to calculate the body mass index, we need height in meters. So we first want to convert our height to meters. And from centimeters to meters, you divide by 100. So mutates, we use height divided by 100. Okay, so we've done that. We put in our pipe operator. And then we now do our body mass index. So we say it's mass all over height raised to the power of 2. So we've found our body mass index. Then next is we are working with human species. And we know the species variable has other values apart from humans. So we can ask R to filter species. We want only humans to be in species. And then, so we are going to ask R to group, because we want to look at the body mass index in females and in males, which is under the gender variable. So we're going to ask R to group this our information by the gender variable. And then